Recently, the internet has been set ablaze with the introduction for the public OpenAI's ChatGPT, Google's LaMDA, Metaverse's Llama, Microsoft-Nvidia's Megatron Turing, Amazon's Code Whisperer, and many more excellent examples. They rely on a subsection of machine learning called large language models that have already shown to be both quite useful and potentially dangerous. First, what is large language model?
Large language model, LLM, is a type of machine learning model that utilizes deep learning in natural language processing, NLP, in natural language generation, NLG tasks. It is designed to understand and generate human language.
What are the uses of large language models?
1. Generate text in a variety of styles and formats, and communication of different types when needed. 2. Generate complex solutions for the tough problems in everyday life. 3. Translates text from language to language. 4. Determines the sentiment of a given text and answer questions posed in natural language. 5. Create reimagined search engines, tutoring chatbots. 6. Composition tools for poems, stories and marketing materials, and more.
Which forms of technologies are used in large language models?
1. Transformer architecture. The transformer architecture is based on the concept of self-attention, which allows the model to learn contextual relationships between words and phrases in a given text. The transformer architecture has several advantages over earlier neural network architectures for NLP. It can capture long-range dependencies between words and phrases. It can attend to different parts of the input sequence at the same time, and it can be trained more efficiently than other architectures using techniques such as parallelization and masking. 2. Attention mechanisms. Attention mechanisms are a type of neural network architecture that allow a model to focus on specific parts of the input data, rather than processing the entire input sequence at once. These mechanisms have been instrumental in improving the quality of language models. 3. Pre-training, fine-tuning, prompt tuning. The goal of pre-training is to teach the language model to understand the structure and meaning of language so that it can be applied to a wide range of downstream tasks. Large language models are typically trained on datasets large enough to include nearly everything such as books, articles, websites, and so on. Fine-tuning refers to the process of taking a pre-trained language model and updating its parameters on a specific task or dataset. The language model can be fine-tuned on specific downstream tasks, such as language generation, sentiment analysis, or question answering. Prompt tuning, on the other hand, refers to the process of modifying the input prompt or conditioning text to guide the generation of text from a pre-trained language model. The prompt or conditioning text provides context and constraints to the model and can be used to generate text that is specific to a particular domain or task. Prompt tuning is a form of few-shot learning, where a small amount of task-specific data is used to fine-tune the model on the task, while leveraging the pre-trained model's knowledge on a large corpus of text. 4. Machine learning, deep learning, transfer learning, multitask learning, in-context learning, and 0/1/few-shot learning. Machine learning is a subfield of artificial intelligence that focuses on developing algorithms and statistical models that enable computers to learn from data. Large language models use ML algorithms to learn the patterns and structures of human language from large datasets. Deep learning is a subset of machine learning that involves training neural networks to perform tasks such as language translation, sentiment analysis, and speech recognition. Multitask learning involves training a language model on multiple related tasks simultaneously. This can help the model to learn more robust representations of language that can be applied to a wide range of tasks. In-context learning is a technique used to improve the contextual understanding of a language model. This involves training the model on specific contexts or domains. 0/1/few-shot learning are used to enable language models to generalize to new tasks or domains with little or no additional training data. Transfer learning is a technique that enables large language models to leverage pre-existing knowledge from previously trained models. This enables large language models to learn new tasks faster and with less data. 5. Natural language processing, NLP and data processing. Natural language processing is the backbone of large language models. NLP is a subfield of artificial intelligence, AI, that deals with the interaction between computers and humans in natural language. Data processing, large language models require vast amounts of data to learn from, and processing this data requires specialized technologies, such as big data tools like Hadoop and Spark. 6. Model optimization. Large language models need to be optimized to ensure they run efficiently and accurately. Optimization techniques such as pruning and quantization can help reduce the size of large language models while maintaining their performance. 7. Distributed computing and cloud computing. Large language models require a lot of computational power to train and run. Distributed computing and cloud computing provides on-demand access to powerful computing resources, which can handle the massive amounts of data and computations required. 8. GPU acceleration. Graphics processing units. GPU can accelerate the training of large language models by performing calculations in parallel. GPU are particularly effective for deep learning algorithms, which involve a large number of matrix calculations. Large language models have a wide range of applications across various industries.
How they may shape our future.
1. Conversational AI. Large language models can be used to create chatbots and voice assistants that can carry on conversations with humans in a natural and engaging way. 2. Language translation. Large language models can be used to translate text from one language to another. This can be useful for businesses that operate in multiple countries and need to communicate with customers who speak different languages. 3. Search engine optimization. Large language models can be used to develop highly accurate search algorithms that can provide relevant search results to users, such as Bing Chat. 4. Financial advisors. To summarize earnings calls and create transcripts of important meetings, while credit card companies can leverage large language models for anomaly detection and fraud analysis to safeguard consumers. 5. Medical diagnosis. Large language models can be used to analyze medical data, such as patient records and lab reports, to assist doctors in making diagnoses and treatment recommendations. 6. Life science researchers. Large language models can be trained to understand and analyze complex biological data, such as proteins, molecules, DNA, and RNA. By processing and interpreting this data, researchers can gain new insights into biological systems, can also be used to predict the structure and function of proteins and molecules, develop new treatments for diseases, and so on. 7. Education and training. Large language models can be used to create interactive educational materials, such as online courses, quizzes, and games. This can make learning more engaging and personalized for students. 8. Data analysis. Large language models can be used to analyze unstructured data, such as customer reviews, social media posts, and survey responses. This can help businesses to identify trends and insights that would be difficult to find using traditional data analysis methods. Large language models are a powerful tool that can be used to drive innovation and improve many aspects of our lives. However, it is important that we also consider the ethical and societal implications of their use and work to ensure that they are used in a responsible and ethical manner.